So we had completed section 8.2 in our previous class, but I guess if you had some hard time finding out the p-value. So I'll give you a small note at the end of this note section here. Huh? So you can do that. Okay. So to find the p-value, so if it is a left-tailed test, that is, if your p-value is greater than some number, less than some number, k. Okay, so k can be any number, some number. Now, how do you find p-value? You use normal CDF, right? So normal CDF in your calculator, that is second and VARS. Now, the question is what to enter here. Now, if it is a left tail, try to enter it as minus 10,000 and then your Z value. Let me put this as Z. Z is less than some number K. Okay, so use 10,000 instead of 9999. So that sometimes you get 10 power minus 15. That will reduce to 0.0001. Okay, so you can do this, and if you have right tail, if it is a right-tailed test, that is if Z is greater than K, then normal CDF will be Z value with 10,000. Now, if you have a two-tailed test, that is, if you have mu or your population proportion is not equal to some number k, then which value you have to use? You can use any value. It can be left tail or right tail. So we generally use the left tail so that you don't have to subtract the area. Now, only difference here is after doing the normal CDF, you get the area, right? So you just have to multiply this area with 2. When it comes to two tail, you just have to multiply the area with 2. That's the only difference. Okay, so you can make a note of this. It will help you when we are solving section 8.3. One. So we will do one example of section 8.1. Example 3. Okay. So the question is, was found that 821 crashes of mid-size car with 8 bags, 46 of it crashes resulted in utilization of the drivers using significance level, that is alpha equal to 0.01. You have to test the claim that the airbag hospitalization is lower than 7.8% rate cars automated safety Okay, so let us, we all know the steps here. The first step is to write the null and alternative hypothesis. That is step 1. Now, null hypothesis H naught. So this is about the proportion. Now, null hypothesis will be 0. Let me write it like this. It is 7.8%. So, which is 7.8 divided by 100. That gives you 0.078. Okay, so this is your claim, testing the claim. So 7.8% rate is the claim you're doing now. Alpha is the significance level, and 821 will be the sample size, 46 will be p cap. This example is quite different. You will see why. Okay, now this is alternative hypothesis. So since here we are saying test the claim that the airbag is lower than 7.8% rate. So p-value is less than 7.8% or it is less than 0.078. Now since it is less than, so it is a right tail. Sorry, left tail. Left-tailed test. If p-value is less than, it is a left tail test. So you have to use normal CDF in this way and find out the area. Okay, before that we need to find the test statistic. So we used to find critical value and statistic both. So since we need only test statistic to find the p-value, I will go ahead with the statistic. Now you all know how to find the z here. Just use the formula p cap minus p divided by square root of p into q divided by n. Now we know that p is 0.078. Now what would be p cap? Yes, 0.056. Why? Because they have not given the probability of the sample proportion directly, rather they gave it as 46. Now, since we need to find the probability would be the favorable outcome divided by total number of outcome. So here, total number of outcome is 821, which is En. So we will divide 46 by 821. That will give you 0.056. So probability P cap, P, Q, all these three are probabilities. Okay, so the value has to be less than 1. Okay. Now that we have everything, so you can also find Q here. Q will be equal to 1 minus P, which is 1 minus 0.078. That gives you 0.922. Okay, you just have to substitute that here. 0.056 minus 0.078 divided by square root of P will be 0.078, Q is 0.922 divided by small n, that is 821. Did you get the answer? It is P5. Okay, so this is your z value. Now all you have to do is to find the area. So to find the area, you all know that you use normal CDF here, normal CDF. Since it is a left tail, I use minus 10,000 here and minus 2.35 on the upper side. So when you do this, you will get the area as did you get the area? How much is that? So that's your p-value. P-value will be 0.004994. So now all you have to do is compare this p-value with alpha. Now let's do our initial conclusion. P with alpha. Okay. So p-value is 0.0094, but significance level alpha is 0.01. Now it is clear that p is less than alpha. P is less than alpha. So now if p is less than alpha, what is the conclusion? So let's go back to the table here, to the first table in the first page. Okay. So if p-value is less than alpha, you're going to reject H0. So we will write here as reject H0. That's the only thing you will write in the initial conclusion. Now, how do you make a final conclusion? It is reject H0, and which is your claim. Your claim is what? H1 will be your claim. How? Because they say it is lower than. It is lower than. So this lower than is present here. So this is your claim. This is your claim. Okay. Remember this. Initial conclusion is rejecting H0. Reject H0 and claim is H1. So go back to the table here. To make the final conclusion, reject H0, claim H1. That would be sufficient evidence support the claim. Okay, sufficient evidence support the claim. So we will make our final conclusion like this. There is enough evidence to support the claim. That's it. This is how you have to solve these problems. It will be very easy. You just have to write the H0, H1 and then find out test statistic. From there you will be finding out p-value and then you will compare p with alpha. If it is less than, you will say reject H0. If it is greater than, you say reject to fail to reject H0. Depending on that, you will make the final conclusion. Okay. Now let's move on to section 8.3. This is about testing a claim about a mean. So in section 8.2, we did testing a claim about a proportion. So in 8.3, we will do testing a claim about a mean. So this section will be the end of your chapter 8. Okay, now the sample must be a simple random sample, this we know. And here the value of the standard deviation is not known. So that's the only difference. Sigma is not known. And then the population is normally distributed, or generally we get n to be greater than 30. And these are the notations. You have been studying this from chapter 1. Now these are the general steps. So this is what you followed for a proportion, testing a proportion. So you will be following the same thing while you are calculating the mean. Okay, now let's start with example 1. This is quite easy. They say it is left tail test, n is given, find out the, even the test statistic is given, t is also given, find out p-value. So all you have to do is use normal CDF. Second, this is t value, right? So t in the sense it is t distribution. It is t distribution. So you use normal CDF, but you also calculate DF. DF means degree of freedom, that is n minus 1. So whenever you have a t distribution, you calculate degree of freedom. Okay. Now to find the area, to find the p-value for the t, when t is given or t distribution is given, you can use TCDF in your TI-83. That will be second vars, and there you will find TCDF, and then you can substitute as 999 minus 0.855 will be your t value, comma 11. So how did I get this 11? It is n minus 1, 12 minus 1, which is 11. So this is like this. This is your lower value. This is the t value, whichever you get, t value, and this is the df value. This is t, c, d, f. And this is how you find the p value or the area. You go to second, was here, and you click on TCDF, which is number 5, enter, and you enter minus 999, comma, minus 0.855, which is the t value, and degree of freedom is 11, and then close parenthesis, enter. Did you all get the answer? Looking for second was TCDF 99, plus 0.855. Point 205 is the correct answer. Point 855, comma 11, close parentheses, enter. And the calculator is okay. So if you do this, you will get the answer as, or the p-value area will be 0.20. So likewise, do for the second example, find the p-value. P-value will be equal to TCDF. It is a two-tailed test, so you will be writing minus 999 here, and t-value is minus 1.577, and your DF is 8. So you can use left or right tail test. That's fine. So your DF, degree of freedom here, will be n minus 1, which is 9 minus 1 equal to 8. And here your answer will be, when you calculate this, you will get 0.0767. But this is your area, but p-value will be equal to 2 times the area whichever you get. Okay, since it is a two-tailed test, you will be multiplying with 2. So your final answer will be 0.153. Okay. Now let's do another example, finding out, testing a claim. Now we have a set of numbers and we have some given data here. So let's find out what is the given data. Given data will be n is given, which is equal to 12 here. N is given, x is given, we will see what it is. X is equal to 6.83333. Use all the numbers because they have not rounded it up. So S is equal to 1.99240984. And alpha is given, significance level 0.05. 0.05 is the significance level of the alpha. Okay, now that we have here, so let us write the H naught first, which is mu, because since we are doing it for mean, you will be representing this by mu. Mu is equal to 7 hours, that's the claim. Test the claim that the mean amount of sleep must be less than 7 hours. Okay, that is the claim you are doing. So this is how you write the null hypothesis, and alternative hypothesis will be less than 7 hours. So this is the claim we are doing. And since it is less than, this is a left-tailed test. You can find the critical value even though we are not using it. That's fine. So critical value will be T alpha by 2 comma df, which is equal to T 0.025 comma 11 equal to minus 1.796. Now, why do we have to use T distribution when it is not mentioned? In section 8.1, we have a formula tables where I told you that when standard deviation is not given, we have to use T, right? So that is why we are using T here. Okay. So once you do this, now this is your degree of freedom. Degree of freedom will be equal to n minus 1, which is equal to 11. So you can use inverse T in your calculator and you can find the area. Okay. Inverse T 0.025 comma 11 as your degree of freedom, and you will get this value. Okay. So once you find the critical value, next step is to find the test statistic of the T value, which is x bar minus mu of x bar divided by S whole divided by square root of n. Now, what is this mu of x bar? That is your population mean. X bar is your sample mean. Sigma is the population standard deviation, whereas S is the sample standard deviation. So S is given, X bar is given, population mean is also given. All you have to do is clean. Okay. So here X bar is 6.833. Okay. So even though X bar is not given, if X bar is not given, you can just add the whole thing and divide by total number of numbers present there. So you will get 6.833. So this is your X bar. This is your X bar. The bar is here, which is written here. You can write there. Okay. Now population mean will be 7, right? Because mu is 7 here. Mu is equal to 7. That's your population mean divided by sample standard deviation is given 1.99240. 1.99240,984 divided by square root of n. N will be 12. So when you do this, you will get minus 0.290. Okay. So once you get your T value, next step is value. Now, since it is a T distribution, you will use TCDF, and that's the left tail. So use minus 9999 and minus 0.29 will be your T value with degree of freedom, which is n minus 1. 12 minus 1 is 11, and you will get the answer as 0.3886. So you will keep this as it is. You will not be multiplying with this value with 2 since it is a left tail test. You will keep the value as same. Now that we found p value and we know the alpha, which is 0.05, all you have to do is state the initial conclusion. Now, is p less than alpha? P is 0.3886 and alpha is 0.05 given in your example. Now 0.3 is greater than 0.05, so it is fail to reject H0. Fail to reject H0. Okay. Now we know that the initial conclusion is fail to reject H0. And what is the claim? Claim is H1. Go back to the table here. Fail to reject, claim is H1, so it is going to be insufficient evidence but support the claim. So there is, we do not have enough evidence, or there is insufficient evidence to support the claim. That's your final conclusion. You just have to repeat the steps which you did for section 8.2. Okay. Now I will leave this problem to yourself. Find the answer and tell me the final conclusion. Okay. So example 3, stating H naught. Check whether your answers are correct or wrong. So this is your null hypothesis. Your alternative hypothesis will be less than 98.6. Now this is the claim. Since it is less than, it is a left tail test. So since it is a left tail test, you use alpha, comma, degree of freedom. So alpha is 0.01, degree of freedom is n minus 1, that is 34. You have to use inverse t, 0.01, comma 34. That will give you negative 2.441. Okay. And then you calculate the test statistic using the formula which is given above. So I'll write the values here. 98.2, that's your sample mean. Population mean is 98.6 divided by standard deviation is 0.62 divided by square root of n, that is 35. When you do this, you will get t value as negative 3.817. So now that we have the t value, all you have to do is to find out the p-value using TCDF. So since it is a left tail, you use 999 or maybe one more 9, that's fine. So negative 3.817 as your t-value, and degree of freedom will be 35 minus 1, which is 34. So your area will be approximately 0.00027. Okay. Now that you have p-value, you just have to compare this p-value 0.00027 with alpha. Alpha is your 0.01, 0.01. So this is definitely less than alpha. So you see reject H naught. Now go back to the final conclusion, rejecting H naught, claiming H1, reject H naught, reject H naught, claim H1, you have this. Sufficient evidence supporting the claim. So that's your final conclusion. There is enough evidence to support the claim. So inverse t will be there in your calculator. You just have to click on second pass. And what is the number corresponding to inverse t? You just have to click on second pass. Yes.
I don't see it anywhere on here. Like I'm looking for it and I don't see it.
Okay, let's see. Yeah, so where did you find the inverse t in your calculator? How did you do that? Hmm. Okay, it's number 4. You find inverse t.
Okay, because it just says TPDF, so it doesn't have the inverse in front of it. So I just wanted to make sure that that's the right one.
So, are you using TI 83 or 84?
83.
Okay, so students are using 84 here. I think this is 80.
The one that you have there is the exact one I'm using.
Second.
See how number 4 has that T?
Mm-hmm. Yeah, there is no inverse t in TI 83. I think it will not work, but can you try inverse norm and check whether you get the same value?
Okay. No, ma'am.
Program. Can you do this? Click on program and you have to click on execute exec and then you will find inverse t in the first one.
When I hit that, it just gives me a black for me to go to the next. Yeah, like exactly like that. It doesn't give me the INT or INVT.
And let me do this. Okay, just try to do this and see whether you get the same answer. Go to stat, and hit your left arrow and go to test, and then just scroll down and go to number 8, T interval, enter. And for get it as expire. Sure, no problem. So just click on stats, and in X bar just enter the value whichever you have and keep C level as 95, and then check whether you get the answer or not. Get the interval. Okay, so I'll just check this and I'll get back to you. Okay,
Okay, thank you.
and you're Miss Erica, right?
It's Alicia.
Okay, Alicia.
Thank you.
Just remind me again if I did not reply.
Okay, thank you.
Okay, so I'll just finish example number 4 and then we will be done with chapter 8. Now this is the same thing. I will give you the final answer and you can just check your answers. So H naught will be mu equal to 46,000. So that's the claim. Okay. Now null alternative hypothesis will be mu not equal to 46,000. So this is a two-tailed. Now you will calculate the critical value. We will skip this only for this example. Now test statistic, G will be equal to 4, 5, 6, 7, 8. That's your X bar. 46000, that's your population mean, divided by standard deviation as 99,000, 9900. It's given. Square root of n is 27. So if you do this, you will get it as negative 0.169. So once you do this, all you have to do is calculate the p-value. You just have to use TCDF 999 minus 0.169, and the degree of freedom will be 26, 27 minus 1, and you get 0.20. So your p-value will be 0.20. Okay. P and alpha 0.20, alpha is 0.05. So P is greater than alpha, P is greater than alpha. So your initial conclusion will be fail to reject H naught. Fail to reject H naught. Okay. And you can write the final conclusion. Just go to the table and you can decide the final conclusion then. So that will complete your chapter 8. I was planning to go over the lab 8 also, but I will see if I have time in the next class. I'll go over the lab 8. Okay, that's your end of chapter 8. I'll post the notes and the video.